So our last speaker for our session today is Koji Sakai, an ACI honorary member. We're very lucky to have him here. He hasn't been to an ACI convention for a while. I've been lucky enough to work with him for quite a while with FIB, the Fédération Internationale du Béton. In the area of sustainability, I consider Koji to be one of our forefathers related to sustainability. He is a representative of the Japan Sustainability Institute, and he traveled all the way here to impart some of his words of wisdom. So appreciate everyone sticking around. He is going to talk about the DE carbon neutral turmoil, right? And we'll just get you mic'd up here and we'll be ready to go. Oh, you already have it. You want to give it a test, Koji? Is it on? Do you want to test your microphone?
Yeah.
Is it on? Can you guys hear?
Maybe we need to
I think you need to
do something.
We'll get this on.
Can you hear me? No. It didn't work.
Try again.
Okay.
Can you hear him?
Can you hear me?
Yes. Yes.
Okay. So you might see my face. I also want to see the face of my audience, but I have some problem. And let me talk my presentation by sitting in my chair. Okay? Okay. So today's title of my presentation is officially, officially this is the title. Carbon neutrality and sustainability design of concrete structures. But my original title was the carbon neutral turmoil. You know, if you say that carbon neutral, it's not so easy. There's some turmoil. So I want to speak about how to consider the carbon neutral, the essence of carbon neutral. Now, what can we do for that? That is my presentation anyway. So I hope that you can understand what I mean. The CN turmoil. Okay, let's next. All of you know that the development of cement concrete technology. John Smeaton in UK, they used hydraulic lime as a joint. Okay. Okay. As a joint material for granite blocks in the construction of a lighthouse. It was 1756. And then we all know that Joseph Aspin was granted a patent for the method of producing hydraulic cement. It was 1824. And there was one Japanese, Isamu Hiroi, began 100-year mortal durability test in 1897. So we published a book for this project. But anyway, there has been a great development until today. However, we used we have used coal to manufacture cement. The steel production is the same. Now we have the argument on the U.S. steel takeover, but in the case of steel production, is the same as the cement production. So what is the decarbon neutrality turmoil? So I would like to clarify what to do now with a clear vision on the nature of a neutrality in the field of cement and concrete, and then discuss measures to take steps forward toward this historic transformation. I would say historic transformation to carbon neutral. So this is not so easy. But we need to know what is concrete to understand the essence of concrete. The concrete is a quite simple material that combines aggregate, which accounts for about 70% of its volume. This is very important. Not so much we can do because of that. And with the cement hydrates, just aggregate cement hydrate and water. Aggregate is the most abundant material on the earth. And also water is the same, which is necessary for hydration of cement. And we are using limestone as a raw material of the cement. It's a substance that have been produced by living organisms over a long time. Therefore, we can say that concrete has the characteristics of a material that we can use in large quantity. This is the nature of the concrete. So when we consider carbon dioxide and carbon neutral, we need to pay attention to the essence of the concrete. And then we have been discussed global warming and carbon neutrality. I would say that modern society has been created by use of fossil fuels. It is causing a global warming, as you know. So because of that, human being, we have decided not to use fossil fuels to realize carbon neutrality in the future. In the future, this is very important because right now there is a limitation which we can do. And let me talk about sustainability, which is related to carbon neutral. So the United Nations defined sustainable development. It says that meets the needs of the present without compromising the ability of the future generations to meet their own needs. You can see that book, Our Common Futures. It was defined 1987. So from this definition, we realize that the goals of the economic and social development must be defined in terms of sustainability. And the environmental capacity has its limitation. Therefore, sustainability can be evaluated through environmental, social, and economic aspects, which was confirmed. I confirmed this fact in the East Japan Great Earthquake. So I wrote this fact in my book, Sustainable Use of Concrete, CLC Press. So the question is how to realize sustainability in concrete structures. First, we need to have a conceptual design in which PATs and their alterations are taken into account. Then from that, then we extract the performance requirements on social, economic, and environmental aspects. If you look at social aspects, which include, of course, safety, it is very important. Nowadays, the people say that resilience and ethics. Resilience can be expressed by safety, so nothing special for that. We have the Asia Building Code. This is mainly safety aspect. And also FIB Model Code, which we have just published. And how about economic aspect? My previous presenter about talking about economic, how much per ton. But this is also important and for life cycle management. FIB Model Code include this aspect. And environmental aspect, this is climate change, CO2, and natural resources, and waste, and contaminations. And the FIB Model Code include this aspect. And also ISO standard 13315 series, which I founded in ISO. And we have developed this standard. So by using this standard, you can evaluate, calculate the environmental impact, how much you emit the carbon dioxide. So this is the one procedure. What is the carbon neutrality turmoil? As Dean mentioned, that the Paris Agreement was adopted in 2015, which is a global plan to keep temperature increases well below 2 degrees Celsius, about pre-industrial levels, but pursue efforts to 1.5 degree in Celsius. And you know that the COP28, which was held the last November, December, they decided away from fossil fuels. So this is very important, a next step, which we have to aim. There is no exception in the concrete industry, but it seems there is still some turmoil in our industry in which the essence of carbon neutral is not being understood. The main part of the turmoil, the fossil fuels. So we need to quit the utilization of fossil fuel. This is one of the most important. That's from fossil fuels to renewable energy. And we set the target by 2030. One is the tripling the renewable energy capacity. And another one is doubling the energy efficiency. So this is the COP28. If you look at the renewable energy capacity, top 10 countries, according to IRENA, the China, the United States, Brazil, Canada, India, Germany, Russia, Japan, Norway, Spain. But we need to consider the population. China looks very high potential in renewable energy, but they have a lot of the people. So this is the current situation. And then renewable share of the annual power capacity expansion. You can see that the increase in non-renewables energy is decreasing, but renewable energy is increasing until today. So this is the main situation. And IEA, this is a figure. IEA, it's a plan. There are many methodology, PV, wind, hydropower, bioenergy, and other renewables. So until 2030, they are expecting this amount of the renewable energy. And this is the country in the G20, G7. It's the same as this. So and outside that, what is the essence of the carbon neutral in cement and concrete? As you know that the cement production inevitably generates a large amount of the CO2 from its raw materials and fuel. This is the fact. And therefore, in order to get the carbon neutral, the direction is a reduction of clinker, use of supplementary cementation materials, and change of cement manufacturing by using new fuels like hydrogens. If you want to use the hydrogen, right now the cost is quite high. But in the future, I think that it will be decreased. And then, carbon capture, the utilized storage of emitted CO2s. Because we are emitting inevitable CO2. So there are several methods which we have to, the direction which we have to see. So how to do that? The method, we need a rational transition design to avoid carbon neutral turmoil is necessary. This is very important, transition design, how to do that. Outside that, there are many tools for transition design. Fuels, hydrogen fuel is one, and also you may use blast furnace like fires, as my previous speaker mentioned. But we have to be careful the possible replacement of blast furnace slag and fly ash into cement is just 7.3% and 0.27%. It's not so much available. So this is also important. Even if you want to utilize the blast furnace slag, lot, but there is a limitation availability. And then carbon capture storage, you may be able to utilize that like methanation. So this is the CO2 plus hydrogen will cause this one, methane. So if we can do that, there is no limitation. So this is a future important tool. And then I'll talk about the trees and oceans. Because those tools are not enough to have the carbon neutral. I would say that the combination of these two makes carbon neutral possible. Well, I would like to show numerical calculations, how to reduce CO2 from cement productions by using each tool. As you know that the amount of carbon dioxide emission from cement, according to our calculation, is 3.47 billion tons in the world. And how about the possible carbon dioxide reduction? If you utilize hydration, quite good tools, 1.37 we can reduce. But unfortunately, SCMs is not so much, as shown here. And how about the carbon capture storage? There are limitations to utilize this technology because we have the just 9.3% share because other industry also may use. So there is a limitation even in our industry. So this is the amount of the CO2 which may reduce. And then methane is a different story that there are some people, city gas companies are trying to do this in the future in Japan. And you can calculate what is the remaining CO2 from the emission minus reduction, the possible reduction. So it becomes 1.33 billion tons. It is just only 3.4% of the total CO2 emission. I would say that including other countries' emission. So from this fact, I would say that can we require to ignore this small amount to the society? So we don't have to much. But if you want to think the trees and oceans, this is not also unlimited. There is a limitation because the other industries also may want to use. So if you consider trees. This is the capacity absorbing of trees, CO2. So multiply by 9.3%, this is the cement sector share. And how about oceans? This is the potential. And then for cement sector, we may be able to use this amount by using oceans. So this is the summary of this calculation, that the emission 3.47 CO2, and reduction is hydrogen fuel, supplementary cementitious materials, and CCS. The total, and also tree and oceans, is this amount. The total 4.3 billion tons. Amazing, this is carbon neutral, carbon negative, if you consider the CO2 emission. So this is the one calculation which I did. So you may have another tools in the future. So like that, you can calculate how much we can reduce the CO2. But it seems to me there is not many tools in our industries. That's okay. Time is coming. And let me touch the wildfires. This is the negative cascading of global warming. In Canada, quite recently, there was the wildfires. So someone calculated it emitted 1.7 billion tons. So huge. And right now in the US, you have the Texas fire, right? Well, if it is the same, the tremendous amount of the CO2 is emitted by wildfires. And this is the emissions, Canada, USA, and Japan. So 0.57. US is large, 4.8. Japan is 1 billion tons. So if you look at this amount, how do we have to consider this fact? And 2019 fossil fuels IPCC report, just 38 billion tons. So you think that the amount of the and cement manufacturing 3.47, right? This is the total. And cement, this one. And if you utilize the hydrogen, it becomes 2.0. So look at that, the total amount of the CO2 emission. Not so much. And you have the EPA Energy Star certificate. I found recently from the newspaper. According to the newspaper, it says that 11 cement manufacturers received the certificate. 11 cement manufacturers from EPA as a prestigious recognition for being in the top 25% of energy efficiency. So it is important to change, of course, wasteful system So you may be able to have this energy star certificate from EPA. But it is quite far from carbon neutral, right? So this is one factor. And this may be a last slide. The GX bond in Japan, 2023 fiscal year. So our government are going to spend hydrogen ion manufacture and EV battery manufacture and low electricity semiconductor manufacture. How about cement? We have some plans in Japan to use hydrogen and carbon capture utilize. But very slow. But I think that direction is quite clear. So they started consider these things. Concluding remarks. I would say that cement concrete technology accumulated over hundreds of the years cannot be transformed overnight. We need a time. And low cost has been the basis for conventional technological development. But with the carbon neutrality demand a drastic change in the existing technological foundation. So there is a need to make drastic change to the framework of sustainability concerning society, environmental, and cost. We have a lot of the code, but those codes have been developed based on the older technology. If you want to introduce a new technology, so it doesn't work. This is what I would like to emphasize. From that point of view, I would say forget illusion innovation. Probably we need electricity storage technologies because we are producing lots of the renewable energy, but we cannot use that because of the limitation for using this energy. So we need to store electricity and then use when you want to use. And in the future, we may have a nuclear fusion generations. There are some people who are trying to develop this energy. So I would like to propose one thing that, there is a limitation as long as we use the existing technology. So we should encourage cement manufacturers to change the production method to utilize our traditional wonderful cement. This is very important. We have a tremendous of the data. So we don't want to change. So this is for sustainable human society in which the fossil fuel is used and emitted carbon is captured and utilized. Steel is the same, but in the field of steel, there is a trend from the blast furnace to electric furnace, which means that the amount of the blast furnace slag will decrease in the future. So we cannot use much. If we can have a cement like that, then concrete industry can concentrate on concrete technology. So this is what I want to emphasize. What is the essence of our history and solution? Our ancestors had regarded that the Earth is alive. However, what modern humans have conducted are its exploitation from it and its enclosures and the propertization. I call it EEP. So, because of that, we are facing the global warming and carbon neutral realization. The outside the solution is very simple, to quit EEP. And you may know that the Airbus, they have the zero emission project. Probably 2035, they have a plan to sell hydrogen-powered commercial plane. So we can also do in the concrete industry. Even plane companies are trying to find the new direction. So this is my presentation. Finally, I'll show you that. So in the calculation of the CO2, Dr. Matsuka helped me. This is acknowledgement. Thank you for your attention. Okay.
Thank you, Koji.
So time over.
It was well worth it as far as I'm concerned. So I've not seen those calculations before. I thought it's very eye-opening. I've also been a strong fan of hydrogen for a long time. I think that the source of hydrogen is going to be a key issue. Those calculations are obviously assuming it's a green hydrogen, so that it's generated from clean energy or renewable energy. Of course, there's a lot of energy that's required to generate hydrogen, right?
I would like to emphasize the transition design is very important based on the tools which we have. So without doing that design, nothing happened, I think.
Right.
Yeah.
This presentation also emphasizes our work with NREL, National Renewable Energy Labs. Some people might not see the connection there between the concrete industry and NREL, but there is, Koji just emphasized that there's a big connection there. There's a lot of research going on with those folks. I actually had the privilege of touring their laboratories, and 25 different laboratories looking at battery technology and transmission and the transition to electric vehicles and so forth. Very last lab that we got to is a concrete and cement lab. So they're starting to focus on it, which is really cool.